Hi everyone, welcome to this video, and in this video we're going to talk about the roots of polynomial function. In this video it's not yet solving for the roots. However, we're just going to discuss now what are some information that we need when we're talking about the roots of polynomial function. Okay, let's have this one. Oops, for a while. Okay, let's have this. Okay, now when we talk about the idea, first thing is that you need to know how many roots are there in a given polynomial function. And to determine that is that we have now the degree. The degree will give us the idea on how many roots are we talking about, or how many roots are there in a given polynomial function. And then an additional information for this class, or for my class, is that there are kinds of roots, such as the positive real roots, and negative real roots, and imaginary roots. So I'll give one example later about this one. Okay, so let's have an example. So let me just get my ink. Okay, so given a function, f of x equal to 3x squared minus 4x plus 5. Now, when you talk about now the degree, is that the exponent, it's the exponent of the variable with the highest number, so that is 2. Therefore, we can conclude that the number of roots is 2. Okay, are we good with that? Okay, I think we're good with that. Okay, so let me have now the next one. Okay, let's have this one. So f of x equal to 7x to the 4th minus 3x plus 2. Now looking now in the variables, there are x to the 4th and x. So therefore degree is 4. Therefore, number of roots is 4. I think we're good with that. Okay, very good. Let's go to this one. So what if it's in a factor form? Now look at now how many factors do we have. So we have now x minus 2, then x plus 3. So as you can see, when you expand that, or when you multiply the factors, we can say each factor in a factor form that will be counted. This is 1, this is another one. So when you add it up, there will be 2. So therefore, number of roots is 2. Okay, I think we can work that out on that case. Okay, we have this again. Oops. Alright, let's have this one. So what if now if we have this one, it's in a factor, however there is what we call a multiplicity. So you look at now the multiplicity, and that is now the number of roots. So number of roots is 5. It means that there are 5 x minus 3 as a factor. So we'll talk about the roots when we talk about your product theorem. Okay, I think we're good. Let's go with this one. How about this one? So f of x equal to x times the 5th of x plus 7. As you can see, you can count this as 1, and then there's a multiplicity of 5. So therefore, number of roots is 6. Okay, I think we're good. Oops, I am having a hard time using this one. Okay, let me have that. Okay, zooming. Okay, we're good with this one. Okay, let's have this one. So as you can see, there are 2 factors that has multiplicity. So what you need to do is that when you add now 4 and 5, so therefore number of roots is 9. I think we're good with that, right? Okay, let's have now the next one. Okay, now when you talk about the kind of roots, you can study Descartes Rule of Sign, where f of x equal to f of x, number of variation is possible number of positive real roots, and then f of negative x, we count down the number of variation is the possible number of negative real roots. And then we can make now an analysis of the possible roots. So let's look at now. Supposedly normally you get 2 and 1. There would be a very good variation of this one. Okay, let's have an example. Okay, so we have now p of x equal to x to the 5th plus x to the 4th minus 5x cubed minus 15x squared plus 4x plus 12. So technically, we want to count first the p of x. So let's look at now the number of variations. So we have now x to the 5th plus 3x to the 4th minus 5x cubed minus 15x squared plus 4x plus 12. Now, when you talk about the variation, it is counting now a consecutivity of plus minus or minus plus. So let's look at this one. There will be a consecutive of plus minus, that's 1. Another here minus plus, and there will be 2, right? So that's how it works. So that's how you count now the number of positive real roots. So we can conclude now there are positive real roots. So positive real roots would be 2 or 0. Whenever you got higher than 1, you deduct by 2 until you reach 0 or 1. So we have 2 and or 0. So there's a possibility that there are 2, 0. Now, when you talk about now the negative real roots, what we need to do is to substitute negative x to the function. So as you can see, x to the 5th, negative x to the 5th, let me just have this one, plus 3x to the 4th minus 5 times negative x cubed minus 15x negative x plus, let me just put it here for the negative x plus 12. And then I need to write it here. Let me just get another color of pen. So there will be a variation. I'm going to use now the orange one. So p of negative x, that will lead us to, will be negative x to the 5th plus 3x to the 4th plus 5x cubed. Is this squared? Yeah, I think this is squared. So that would be minus 15x squared minus 4x plus 12. And then we count now the variation of plus minus. So as you can see, there will be 1, 2, and then 3. So therefore, when we count now the negative real roots is 3 or 1 because you deduct 2. So there are possibility, and then we're gonna make now the analysis. However, that will be given on the next video. So I hope you learned something about the roots of polynomial function. Okay, thank you for watching this video and have a great day.